Yes, this one. Yes, thank you. Can you put lecture number correct, please? It's 10, I think. Thank you. Okay, so I explain you a bit about the modeling. Now I will show you what we are doing in terms of observation. So it will be, I will try to do this in 30 minutes. So urban observation. So this is just an introduction. So this I already explained you, all the process that you need to observe. So you need to observe all this process.
I have one question.
Yes?
The short wave is have high intensity, but long wave is very low intensity, right?
Yes, yes. So, but we have,
It is important.
it is very important. We have also, you need to put pyranometer, I think, or some
Pyranometer.
yes, to measure how much is outgoing.
Outgoing radiation.
Yes, this is what we measure. So we measure the downward and the upward. Yes.
So yesterday I showed my presentation in which we found the very close buildings.
Yes.
Slum rehabilitation areas.
Yes.
They have nighttime heat stress because of this.
Of this, yes. You see, so it's really,
And
yeah,
the Skyway factor is also very less.
reduced.
Reduced.
Yeah, yeah,
Trapping of air.
yeah,
and
yeah.
this. But it will be good to measure this long wave radiation in a particular environment.
Definitely, yes, definitely. Because
and
it,
will also depend upon the materials, right?
exactly, yeah, definitely, yes, yes.
So it is a cumulative impact.
Accumulative, yeah. So you need to see, for example, which area it's vulnerable, and then you go there and then you measure. And then you evaluate with your model, if the model can reproduce this. Yes. Okay, so you would like to measure, to put observation in cities. The first thing is that cities are heterogeneous. So it's not homogeneous, your city, of course. So here I take this from the paper of Professor Merota and Rakesh. This is the surface heat island intensity, and this is Bhopal. And you see that it's negative, even here, in the urban area. So, and you see that here it's negative, here it's positive, you have the lake. So this is the, for the city of New York. So you would like maybe to observe here, but you need to know, but maybe this point, is it representative of all this area or not? So this is the, you need to select where your city is not homogeneous. First, select where you would like to observe, which part of the city you are interested on. So because the city is not the same. If you put it in near the lake, it will be affected. If you put it in suburban, it's different. If you put it in pure urban, in the slum area, it's also completely different. So it's very important to first select where, in which part of the city you would like to put your measurement. So here I will give you some, this is the city of Ghent, okay, in Belgium. And we put, so we have the city, and we put 6 stations. So 6 stations. So we select 6 locations. And we put such type of measurement you can recognize here. So we measure, it's here. Yes, measure parameters. So we measure temperature, precipitation, relative humidity, and wind speed. So these 4 parameters. And we have 6 locations like this. But the challenge, I will tell you that we had a big challenge to finding the location. Why? Because the first thing was that we need electricity with this. Where to put the electricity. So you need a location where. But later you will see we are using a solar panel with this type of. So then but there is a lot of challenge. So first, finding location. The second one is the relative humidity sensor was a bit difficult to find a good one because we had some problem with this sensor of the relative humidity, which was not very accurate. And then if you do precipitation measurement here, what does it mean to measure precipitation in this area? Because it will be very, very affected, the precipitation, by the wind, by the fact that you have a wall. So how to interpret? the observation of precipitation is really a challenge. For temperature is okay because you can relate it to urban heat island, etc. But for precipitation, really, it was a challenge how to. So we buy a high accuracy sensor. It's Campbell Scientific, which about 5,000 euro per station. So this station 5,000 euro. And we have real-time data available, a logger, etc. So, and then 6 stationary stations, good contact with the responsible of location. So you need to have a good contact because if these people don't agree to have your measurement in their site, so we have sometimes we write we sign a contract with the person for 5 years and yeah. So it's a lot of challenge to put measurement. So we finally succeed to put 6 in 6 locations. Okay, and one thing that we do here is so with this location, I will show you again. So we have 2 locations in a dense urban area, 1 location in suburban, and 1 location in. So this location here is this is the rural one. So we have 2 stations in the city center. We have 1 station is here, it's suburban, you see, it's outside the city. And we have 1 in the urban park. So we have an urban park here. And we have another one in industrial area. So we wanted to know different local climate zone. You have the lecture by Professor yesterday of local climate zone. So we wanted to know for different local climate zone, what is to observe in different local climate zone. So the first thing we use with this observation is that, I said this to you yesterday, but we was able, for example, to study what is the impact of lockdown. You know, when we have a COVID, we had the lockdown in 2020, and we wanted, because we start this measurement in 2016, okay, 2016, 17, okay. So we had some years before the lockdown, and we just compare the observation of 2017, 18, 19 with the one of the COVID, 2020. We wanted to know how the urban heat island changed during the COVID period, the lockdown. So if you look to this is the Sint Bavo, is the city center. So this is the dense area, this one, and also this one. What we found, so here you can recognize urban heat island for the different years. So 2020 is this color, I don't know how to say this, it's yellow, and the other years, it's the other colors, okay? So what we found is that, so this is the hour from 0:24 here. So what we found is that at 16 here, so at the end of the afternoon, the urban heat island decrease. And we found this for Sint Bavo and also Provinciehuis. So this is the city center also. And we found also in here this is the park, urban park. Yes. So we found this, it means that the fact that, because during the lockdown, you don't have cars. So all this traffic, it's because the cars there was a ban of using cars. So the street there was no car passing the street. So all this anthropogenic heat that I told you of the traffic was 0. And we wanted to know, during the lockdown, is this impacting the urban heat island? And we found that it's really impacting. So the fact that you don't have traffic will decrease the urban heat island by 0.6 degrees. So this is so such type of observation is really beneficial for this, yes.
What height?
2 meters, it's the canopy, yes.
Okay, so every city has that same center observing the air temperature.
Yes.
It's on basis of air temperature?
Yes, yes. We have two places here in the city center. This is city center. This is park, urban park. And this is industrial area, and this is the suburban area. So we don't see, like in the industrial area, any impact, but we saw the impact in the urban very well. And this was, we do a statistical test to check, and we found that these 2 was the only 2 which was statistically significant. So we have a decrease of the urban heat island during the COVID. So you can also measure the observation. You can use car. You can use car. Yes.
So can we go to the previous slide?
Yes.
In general, that point of time for 2017, 18 and 19 is low at 60.
Here. Yes. Yes.
Why is it so?
Yes, that's a very good idea. Because the urban heat island normally is higher during the night in our city, in higher, and then during the day is decreased. And this, why it is low here, because this is the point where if you look to the surface energy balance, you know, surface energy balance, this at 16, this is where the surface energy balance is all the flux are very weak. If I can plot here, I will explain you. I need to.
You want pen?
Yes. Oh, sorry.
Okay.
I need to explain you on the with the energy balance. Wait, yes, I will explain you this. In fact, is a point where all the flux, the sensible, the latent, the net radiation, we have the 4 flux of the surface energy. You know this, huh? So, but I will explain you. So at 16.
I'll get the board in the next. So in the tutorials we will do that.
In the tutorial, I will show you. Yes, yes. Because it's very, very good question. Because this is where all the flux are 0, and this is where the fact that you have or not the traffic impact a lot. Because the traffic did not impact during the night. Because also during the night there was no. But the only impact of the traffic was during this period, because this is the period where all the flux are very, very small. They are close to 0 at 16. I can show you.
For this particular
Actually, I think it is because of the sun is not there.
Yes.
So short wave radiations are also not there. So those fluxes are also not there.
Yes. So all is close to 0.
All are close to 0.
Close to 0.
Minimum at these.
Exactly. This is the minimum. Yes.
And anthropogenic emission and heat is also not there.
Exactly. Yes. 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 This is where the anthropogenic heat is, if you have or not, the traffic is impacting. Only in this. It is not impacting like at 12 where you have the maximum of radiation. It is not impacting. Or at night. It's impacting only in this area. But I can explain you.
But in the last city, that is Honda,
Yes.
we don't see the same.
Yes, we don't see this impact. This is industrial area. An industrial area. So we don't see this impact here because this impact of surface energy balance is more clear in the urban area, in the dense urban area.
So what is one?
This is suburban.
Suburban and Simba,
This is city center, and this is urban park.
urban park.
Yes.
So the graph that is post just before 10, I guess, the rise that is happening, what time is that in Wandel?
Here it's 16. No?
In here, in Wandel?
Wandelgem, here, yes, here.
No, the rise that is happening, suddenly there is a rise.
Yes, here.
The first, I'll ask later.
Between 10 and 15,
Yes,
she's
between-
asking why.
Yes, 5 and 10, there is a drip.
Ah,
Then
here.
suddenly it is increasing.
Here you mean, here.
At 10 it is increasing.
Ah, at 10, here you mean, yes, here.
Yes, so why it is dipping in 5 and then 10 it is increasing
Traffic time.
and the sunrise.
Also, no?
Sunrise.
So the urban heat island normally you have a big during the night. Then when it's early morning, it's the minimum of the urban heat island, because when the sunrise starts, all this energy is kept. So it's not used for the air. It's kept in the wall. So that's why it will not affect your temperature at early morning. The early morning temperature is the same like rural. So that's why it's minimum. And then you have the sun which is going on, so you have more and more, so that will heat. That's why this little bit of heating of the urban with respect to because the sun is going to the maximum, the solar radiation, so that's why you have a maximum at 12. And then it decreases because here you have a change of the storage. The storage flux, which is the flux which going from it's the heat which is stored in the city, in the building. This we call this the storage heat flux. This storage heat flux, so it increase, and then at 16 it decrease and then change the sign. It's becoming negative. The heat storage becoming negative. It means all the heat which is stored during the day, now it is released, and it is released after 16. and 16 is the time where it crossed zero, from positive to negative. This is why this is here why it's negative. So because it starts to release the heat. So then it's increasing again.
Sir, I think office timing will be also same, 10 to 4 p.m.
Yes, so we thought that it's during the office time, but office time you have at 8 and you have at also end of the afternoon.
Evening.
Yes, but we did not find, but the effect was statistically significant in the end of the afternoon, not at 8. We did not find the statistics at 8. Because at 8 we don't have this storage heat flux going from positive to negative. It's going from positive to negative only at 16.
The release.
The release, yes, the release.
Industrial area, the temperature is lower than in suburban area.
Where?
It
Industrial
is
area.
not temperature, it is the urban heat island. The
sorry.
difference
The
between
difference
urban
in
and rural.
It's a difference in temperature.
It's the difference.
The industrial area of Honda
Yes?
has less urban heat island effect than of water gel.
Yes, here you mean. Yes. Because maybe it's open, because it's industrial area, it's open, so the temperature can still, it's not, the rural station is really rural, it's rural area, but here this Honda is industry, but it's open, still open. So you have also some vegetation, you have industry like big building like this, but it's a bit open. You have also vegetation, you have also trees. That's why the difference is small. Yes. But we were really, it was really interesting to see that the impact is only at 16. Okay. You can also observe using cars, if you would like, here a car, and then you cross, you put measurement. So this is, you can go to this site, so it's in US, they are using this type of measurement to study the city. What we are doing also in Belgium is we are using what we call a citizen science approach. So this is Flanders, it's the north part of Belgium, okay? And then we go to all the schools, you know, the schools of kids, not high school, it's the school of kids. And then we tell them that we will start a new project called Vlinder, where we would like to put measurement in the schools, and that the students, you see here, they are students that will install the station themselves. So you see here we are using solar panels, so we don't use electricity. So then it's okay. And then the students of all these schools, they are installing the station. They are also making the measurement, and they are using this measurement for their study. So they can also analyze the measurement, and they get also like known about all the urban problem, urban heat island. So that was also for education aspect. So here it's much more or less. You see a station. The cost is much more less than the first one. The first one was 5,000 euro. This one is around 1,200 euro per station. And we can also have real-time data. And then we can have more. We have 75 stations. And voila. So we put all this. Sorry. I will come back here. Yes, this one. Sorry. Yes. So we put all these stations. One thing that we use with this station is that this is the biggest place in Belgium. Is Sint-Niklaas. Okay, is the largest marketplace, and the government would like to make some arrangement for this because it's only concrete here. So during heat wave, it's really difficult to be here during heat wave. So what we do is that we have the measurement before and after. So this measurement can be used to check before the intervention of the government, after the intervention of government, what is the impact of the... So that's why it's good to have temperature measurement observation for a long time, because then you can also check if the government will do some intervention. You can check with the observation. What is the impact of this measurement, of this intervention? So the government would like to make this. So now, in 2026, we will see, because we have the measurement running, we have the measurement in this. We are now still at this state, like this. But in 2026, here, so the government will make this intervention here. So we will see what is the impact of because we have a station right in the middle. So we can see the impact of this on the...
proposal for 2026.
Yes.
For the same place.
the same place. So this is one of using this measurement that you can check or
How it can change.
exactly, yes, with the intervention, yes. So for example, with this, we put one station here. We found that the urban park have limited impact on temperature. So limited cooling on warm summer day, less than 2 degrees. However, the impact on heat stress is large due to the shadow. So we found that in city, the shadow is more important than the evapotranspiration for the urban park. Yeah. So this we cannot find without observation. So that's why you need really observation to check such kind of process.
I think, sir, if the city is in dry condition,
Yes.
then the shadow is using much more.
Yes, exactly. Yes.
If it is too humid,
Yes.
then it can be difficult. The shadow cannot affect that much.
If it's humid, you mean?
Hot and humid.
Ah, yes, I see. Yeah. Yes. So it depends on the local climate.
Climate of this city.
Exactly. So what we use also this observation is to check how much of yes, here it was to see if you have freezing temperature. You see. So we start here in 2016, and we found that in the rural area, the freezing starts early, like here at November. No, it's October here. It's October. We start to have the freezing. Okay, it's when temperature is negative. Okay, -6. Until 27 of April. This is the rural. But in the urban, in the city center, the freezing starts later. You see here, it's 29. So it's reduced. So all this information you can have. If you put observation, you can see how much so this is good for the cars. You don't have problem but here maybe you don't have this problem of cold temperature during the winter. But in cold cities, that's really a big issue to see to see the impact on the freezing. We can also check the impact on the buildings. If you put, for example, here, the buildings are very important for them to know how much you go from positive to negative. We call the freeze-thaw damage in the building. If you take a building, so if it's negative temperature, so it will freeze, and then if it's positive temperature, then it will thaw. So the building. So this affects a lot the quality, the deterioration of the building. So this cycle of freeze-thaw in building is very important. You can check this with the observation. So this is what we check here. That's the ice crystallization. You know, all this moisture that go inside the wall. We can check, for example, that this is in a rural area and this is an urban area. It means that in an urban area you have less of problem. So the building will have less because of the urban heat island, because it's always hot, not hot, always adding a degree. You see, so always adding degree. So you will not have this cycle often.
Even the material is different.
Yes, that's also okay, right? But the fact that you go from positive to negative happen much more often in rural area. In urban area, because of the urban heat island, adding this degree, it will not go down because. So you see this type of things you can do. So this is just the measurement. One day we have a difference of 10 degrees for Brussels. So it's really a big difference between the city and the surrounding. We have also like a lake. It's not a lake, but it's artificial lake in Belgium here. And we put also measurement here. We could find that what happened lakes in summer, the lake are cool during the day and warm during the night. But this you know. During the day you have cool island, and during the night you have warm because the temperature of the water is higher than the temperature of the land. So that's why you have a warm during the night. You can also use this type of, you can put on bike. We put this on bike, this type of measurement, we put it on bike, and then we cross another city here in Belgium. It's Antwerp. But yeah, of course, this paper has been published in Urban Climate. So, of course, if you do this type of measurement here, you need to correct. The corrections some needed, like what is the inertia of the sensor here, and then the correction for temperature decline during the measurement. Because when you bike, the time is going, so you need to correct because you are not measuring at the same time. So you need to apply some correction. But if you are interested, you can go to this paper. You see how we apply all this. And then what we do, also is that, so we cross with this bike, but then using, I think here we use machine learning. Using machine learning, you can estimate, so you do one cross with the bicycle, but then you can estimate what is the temperature of the other area, of all the area of this city, which have the same land use and land cover. We did this with the local climate zone. We did this with local climate zone, and then we cross with the bike, we have measurement, and then we apply this to all the local climate zone which are similar to this, and then you can get a map. So without having all this, so you can get a map like this. So if you are interested, you can see this this paper here. So this is another way of doing measurement in a city. And so this we will do after. It's for the tutorial. We will do it later. So this afternoon. Okay.
Thank you.
Thank you.